let's check answers, my dudes.
I told myself I was doing the homework, and then I browsed Newgrounds all night.
Yeah, pretty much.
Oh my god, I didn't sleep last night either.
Except they use for light. So.
And this?
Except
number 9 was 6, correct?
Number 9,
Was it simple math? Can I just like look at it now and figure it out in my head?
6. It's simple math, kind of.
So number 1 is C, and number 2 is C.
What? No, that's not it.
Oh my god, is it literally just the same thing in different reference frames about light? Oh my god, that's wonderful.
Oh, the answer to the first 3 problems.
Oh, I see what you're saying. Yes.
Yeah, you forgot about social relativity, didn't you?
No, I just didn't. I didn't read the question. I haven't done it yet.
I mean, it's C. It's a laser. Lasers are beams of light, so they would move at light speed.
C.
Which means
I'm like,
they're all C.
they're not multiple choice. How can they be C? Because this is what I was thinking. C as in the speed of light.
C is supposed to be the speed of light.
What?
C is supposed to be the speed of light.
Yes, C is the speed of light.
Why is my internet not working? Come on, Insa. You think that like you have so many like computer geniuses.
It's not this
That's
difficult.
why. Because we have so many. It's being used.
Yes.
You got questions? I got answers. Nice.
Are we sure?
They're not as bad per se. It's just we have so many people online.
Yeah.
Any regular high school would probably treat
Why?
if they hadn't seen what we had.
He sees what I've seen no matter what. So then I just like the one.
Is it colder in here than usual?
Here we go.
Is it colder?
Number 1 is C.
Really?
Number 2 is C.
No way.
Number 3 is C. Number 4, it'd be funny if that were C too, right? It's B.
Wait.
Number 4 is B. Number 5 is 12 meters.
Okay.
Number 6 is C. 7 is 12 meters over C, which numerically comes out to 4 times 10 to the negative 8 seconds. Number 8 is 12.579 meters over C, which comes out numerically to 4.19 times 10 to the negative 8 seconds. Number 9 is 12.579 meters, maybe those are out of order. Number 10 is E. Number 11, I'm not going to tell you because if I tell you, I have to do the whole thing anyway, right? You want to understand, you can commence or you can. Okay, no, I'm going to tell you now. The answer to number 11 is yes, but still, the hard part is figuring out why.
I know why. I know why.
Okay,
because I'm
question. Yes. 10.
Are you okay, child?
10.
Only on Monday.
Okay, so this one is important. The part of this problem is this is a Venus and Rosenthal with a light beam instead of a ball or whatever it was before. All the same things apply to the last homework, right? The last homework we had the same thing. In Rosenkranz's reference frame, the ball bounces straight up and down. In Guildenstern's reference frame, he's watching the ball. This is Guildenstern, this is Rosenkranz. Guildenstern's watching the ball, he sees it go like this. Right? Just like we said before, right? We did this problem last month. Nothing has changed except for the speed at which the ball is moving, right? Instead of going at whatever 20 meters a second or whatever it was, now it's moving at C. But we know that we know something special about C. What do we know about C? Good. C has to be the same in every reference frame. The speed of light has to be the same in every reference frame. I want you to think about it from the perspective of the ball, okay? When we had a ball, then, what changes here when we have this? What changed? What quantity changed? The distance had to change, right? Because it's going at a slant, geometrically this is longer. The height is the same, but the distance is the same. Because it's going at an angle now, right? With the regular case that we did normally, right? Your sort of normal traditional way of looking at physics, which is what we did last summer. The distance changed, but what else changed to compensate?
The speed.
The speed of the ball also changed, right? The ball got basically a boost from the fact that the train was moving this way, right? So in addition to having a vertical velocity, the ball also had a horizontal velocity, and that together adds up to a greater total speed. Because of that, the distance increased, but so does the speed. Now, please remind me, what is velocity? Mathematically, go ahead.
It's a vector.
Yes.
Well,
It's
speed
vector.
and a direction.
That's true, but like, how do you calculate it? This is over time.
Yeah.
Remember that? Okay. Velocity is the distance over time, right? RT, rate times time equals distance, right? Do you guys still do RT equality still call those? Nope, guess not. All right, whatever. It's the same. In algebra, we don't call it RT equality, rate times time equals distance. But anyway, it's fine. Do you still geometry? Do you still do CDC? Yes. All right, good. So, just always curious what things kind of like everyone does. So velocity is distance over time, right? Okay, so let's think about it. In the Galilean case, right, the case we looked at last time, the normal case, with the regular ball going at regular speeds, the distance increased, but the velocity also increased. And they both increased by the same factor, because they both had that same kind of Pythagorean thing going on, right? So they both increased by the same factor. So if these both increase by the same factor, the time stays the same, which is what everyone wants to happen. Okay? Now, with this problem, we have a problem, right? And we should expect that problem, because last time we talked about how weird it is to say that the speed of light stays the same in every reference frame. And the rest of this class, well, the rest of this unit, will be devoted to just how weird that is. Okay? Just how weird that is that the distance still changes, because that's just geometry at work. So the distance has to change. But the velocity, the speed, I should say, is not allowed to change. Right? It has to be c. If you have to keep this the same, but the distance has to increase, then what has to happen to the time? The time also has to change, right? Because you're no longer allowed to change the velocity. Okay? So, what Einstein says originally, or the first thing off that Einstein says, is when you have the speed of light is the same in every reference frame, the first thing that happens is that, look, you no longer agree on this distance. That's understood, right? You disagree on spatial coordinates, the x positions change, remember that? You actually also disagree on velocities. We already had that. In fact, let's start making a little list, okay? We already had that position is, and the word we use for this, and different people disagree with it, is, and I guess different people disagree on what the number is, and we say that it is relative. Good. We say position is relative. Because different people, even with the same origin, right? If you're moving, the spatial positions change over time, you get different coordinates. We saw that, right? And then another thing that Galileo said is that velocity is relative. Because you measure velocity in one reference frame, something's not moving, in another reference frame it is moving, right? So velocity is relative. Okay. So now Einstein says, I'm going to have to add to this list. Because if the speed of light stays the same in every reference frame, then that's going to require us to, we already disagreed on this distance. We're also now going to have to disagree on what?
Time.
Time. Okay? So Einstein says now, time is relative. That two people in different reference frames, or two different reference frames, will not agree on the amount of time that elapses. Yeah. Well, why would it? Right? You see, the key velocity here is not the speed of light. The key velocity is the speed of the train. Right? Because the faster the train goes, the more this gets stretched out. Right? And the more this gets stretched out, well, the speed of light doesn't change. Therefore, if this gets stretched out more, the distance is going to increase by more, which means what? Time is also going to change by more, right? So it's not about the speed of light. I mean, it is about the speed of light that's constant, right? But it's not the speed of light that sets the scale here. The scale is set by the speed of the train. Okay? So yes, it works with things that aren't light. This example allows you to figure out what's going on. In fact, let's go ahead and work through this example in general terms. Okay? Let's go through the Rosencrantz's frame. This thing has a height h. Okay? I think I gave you a specific number, but let's just call it h. This is a light beam, so it's got a speed c, of course. Right? How long does it take the light to get, let's just say, from the bottom to the top? Go ahead.
2h over c.
Let's just do bottom to top. So
Oh, bottom to top, so h over
That's
c.
cool.
Yeah.
Yeah, so h over c. Right?
Yeah.
Good. So the time it takes according to Rosencrantz is h over c. Okay? Now, let's look at it in Guildenstern reference. You guys know what Rosencrantz and Guildenstern are? Where are they from? Hamlet. What do they do in Hamlet? And then die. That's right. They're both famous for dying. No? No one read Hamlet? Anybody here read Hamlet? Kids these days, I said, I tell you. There's a line in Hamlet. Rosencrantz and Guildenstern show up very briefly, and then don't really show up for several acts, and then in Act 5, someone walks on stage and says, Rosencrantz and Guildenstern are dead, and then leaves. And so Tom Stopper then wrote a play about this called Rosencrantz and Guildenstern are dead. This modern play about related to that. Anyway, moving on. Okay, so this is how much it is in Rosencrantz and reference frame. That's easy. All right. In Guildenstern's reference frame, the height of the frame has not changed. Okay. But we do know that this distance that the light has traveled is changing, right? Because there is this hypotenuse here, right? And yes, form the hypotenuse of the right triangle. Okay. This leg of the triangle has what length? H. Good. This leg of the triangle is the distance that the train has traveled in time t. How far has the train traveled in time t? If the train's going at velocity v times t, right? So if the train's going at velocity v, it's not going at the speed of light, right? So this is v times t. Right? We don't know what t is, by the way. We'll get it. Okay, but you agree that this, whatever that time is, this is the velocity of the train times that time. That's how far it travels, right? The time it takes for the ball to get to the top. Okay? Great. So now we can figure out what the hypotenuse is. What's the hypotenuse going to be? Go ahead, H.
Square root of h squared plus b squared t squared.
Good. That's just Pythagorean theorem, right? You have a square root on that because you have a square root on, right? That's how it works. Right? A squared plus b squared equals c squared, so this is going to be our hypotenuse. Okay? The hypotenuse, therefore, is the distance here. Right? Okay, good. So tell me, what is the time that Guildenstern measures? Good. It needs the square root of h squared plus b squared t squared over c. Okay, good. There's a problem with this equation. What's wrong with it? No, that's not quite it. It's simpler than that. It's not a real problem. Go ahead.
There's a t on both sides.
The t on both sides. So that means the equation's not done, right? You haven't solved the equation if you have the variable on both sides, right? So what do we have to do? We have to solve for t, right?
Which should be fun.
We all remember how to do algebra. We're going to need to do that.
Yes.
This isn't Math and Science Academy. I don't think I'm asking too much. So, how do you solve this for t? What are you going to have to do?
Let's see.
Good, you have to square both sides, right? Maybe, because I like to get rid of fractions first. You can do this in a variety of orders, it doesn't matter. But I like to get rid of fractions first, so I'm going to multiply by c first. Okay? So you got ct equals the square root of h squared plus b squared t squared. I want to go through this slowly because past experience has showed me that I need to. That some people have forgotten how to do algebra. There's a lot of other things going on, I understand. But, those are useful too. Okay, so to get rid of the square root, what do I do? Square both sides. Okay, square both sides, I got c squared t squared equals h squared plus b squared t squared. Notice that squares are hard to work with, right? You can't, this is not the same as h plus b t squared, right? Because squares don't work that way. Okay? Alright, we want to get the t's together, what do we do?
Square root.
Yeah,